A fairly typical experiment that you might do at A level is the potato osmosis experiment. So here is an example potato osmosis write-up that was written for the New University of International School of Thailand. What we have here is the concentrations of sodium chloride in water. What you've got is the time the experiment was carried out. You've got how they did their samples for their potatoes. You've got the salt concentrations. You've got the potato samples. You've got the initial mass in grams, plus or minus 0.01, depending on their scale. The mass after they've been left in the solution, the initial length, and the final length. So this is the original collection of data. There's some observations. Rigid in structure, bendy, not bendy, whatever. The ones in high salt concentration, they shrink and are floppy. The ones in pure water, they end up very rigid. Next thing they've done is some data processing to figure out the percentage change in mass and the average change, percentage change in length and the average change. They've also done the differences this is the same table as before. Don't quite understand why they've done it twice. Oh, they're looking at the difference from the average for each of the different values. So this is a measure of precision. But all of this is derivative data. So the first thing you need to think about with this is, what are you actually trying to do? What's the aim? Well, you're studying osmosis. You're studying osmosis in plants by looking at potato tubers. Now, what does that actually mean? Now, if I continue down, I end up with a graph. So it's telling me that the percentage change in weight is different depending on the salt concentration. It reaches a minimum and then it goes up again on either side of that minimum. You've also got the changes in length, which are less interesting. It's not usually actually a good idea to put two things on a graph and have two different measures like this, length and mass, but it's to show that weight doesn't change that much compared to the change that you get within mass. So what's happening? When you have two things that are isotonic, so that means they have exactly the same ionic strength as each other, then osmosis doesn't happen. Water will not go from one to the other. When I have a higher concentration, I have a higher ionic strength, then the water will go from the lower to the higher. So if I've got a very concentrated solution of salt, then the water will come out of the potato and go into the salt solution. Conversely, if I've got a very low concentration, then the water will go from the low concentration to try and dilute the higher concentration inside the potato, and the water will go into the potato. So this is an experiment that allows me to see how strong this gradient is, how strong this effect is, which would be to create a model of that flow of movement and a model of osmosis. It also allows me to calculate a particular value, which is what is the ionic strength of the potatoes. So what is the point of which osmosis doesn't take place? So I can look at that coming off the particular curve. Or I could simplify down and do a much simpler view of things to say that osmosis happens when there's a difference between the salt concentrations within the potato and within the solution that surrounds it. So that's three different levels of question. one which is a very specific number, which is going to be my answer, one which is a model which could be applied to any kind of concentrations, well, depending on if you want to do interpolation rather than extrapolation, so a model of how it's going. And the other one is a hypothesis sort of test of yes or no. Has the weight of the potato changed because has there been any flow of water in or out of the potato? So I can do hypothesis testing, regression, or I can find a single value by fit to a curve, which is also a part of the regression process. So a relatively simple experiment can have quite a lot of different ways of looking at it. So the first thing to think about in your data is how are you going to put it into some kind of analysis program. What do you want to do? Now, depending on which of those questions you want to do, depends on how you're going to put your data into SPSS, for example. So what I can do is have the measurements before and after as two separate columns. I'm going to focus on mass rather than looking at length, because the lengths, to be honest, change very small percentage. The interesting thing is in the change of mass.